Hey there, welcome to Lesson 8 with the classwork. I'm going to read the learning target first. It says I can use the value of a ratio to solve ratio problems in a real world context. I can use the value of a ratio to determine whether two ratios are equivalent. So, and this piece I left here because it seemed pretty important. When given a ratio A to B, where B is not equal to 0, we call the quotient A over B the value of the ratio. I think that's kind of an important piece in this. So, exercise 1, circle any equivalent ratios from the list below. 1 to 2, 5 to 10, 6 to 16, 12 to 32, and I'm looking at this, and I know I can multiply by 5, then these are equal. What about 16 to 32? I know I'm doubling. 6 times 2, I'm doubling that. So those are also equivalent. Those are equivalent ratios that I just grouped. So now it says find the value of each of these. So leaving your answer as a fraction, but rewrite the fraction using the largest possible unit. So the value of this ratio is 1/2. This is 5/10, but I can reduce that. Divide by 5, I'm going to get 1/2 as well. How about 6/16? 6/16. I know that if I, not by 3, but by 2, divide both top and bottom by 2, and I end up with 3/8 for that one. And then 12/32. If I write 12/32, I could divide that by 4 top and bottom, and I get 3/8 as well. 3/8. Okay, so notice that they have equivalent, the equivalent ratios, they also have an equivalent value. What do you notice about value? Okay, so in little tiny blue here, note that 1 to 2 is not the same ratio as 5 to 10, so we don't say they are equal. The ratios are not the same, but their values are equal. I know, it's a little hard to grasp, I think. We're going to go to, I skipped exercise 2 on the whole theorem and coming up with counter examples, but you could go over that with your classroom teacher. And then this where it says, be prepared to share your answers. If you decide to share when you have a Google Meet with your teacher or you're in class, that's great. Exercise 3. Tavon's training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race, so while Tavon trains, he rides his bike more than he runs. During training, Tavon runs 4 miles for every 14 miles that he rides his bike. So identify the ratio associated with this problem and find its value. So we have the run to the bike, and so I'm going to take the 4 miles to 14 miles, and that is our ratio, and then find the value is 4/14. Divide by 2, I get 2/7. 2/7 is the value, okay? And so I think that's all I needed to do with that one. Okay, so let me move next. Now this is the B part, and it says use the value of each ratio to solve the problem. So what I'm going to just write up here what I did have. I had the 2, it was the 4 to 14, which we said is the value was then 2/7. Okay. When Tavon completed all of his training for the duathlon, the ratio of the total number of miles he ran to total number of miles he cycled was 80 to 280. Is this consistent with Tavon's training schedule? Explain why or why not. So I'm going to take that 80 to 280, and then right below I'm going to write the original ratio we had, 4 to 14. This side, I know as I'm looking at it, is easier for me to 4 times is easier for me to calculate. 4 times 20 is going to give me 80. So then I'm asking myself, is 14 times 20? There's an 8, there's a 2. You know what? It's a workin'. I love that. So, is this consistent with his training schedule? Explain why or why not. Yes, this is consistent. It's consistent because the 80 to 280 and 4 to 14 have the same value of 2/7. They're equal. Okay? Perfect. In one training session, Tavon ran 4 miles and cycled 7 miles. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? Why or why not? So 4 to 7. That's not, because remember how we're looking at the 2/7? So the value of this, remember I just take the 4 and put it over the 7. So this is the value, what they've just given me. But the equivalent ratio of the distance he ran to the distance he cycled, what he was using was the 2/7. So I'm going to say 4/7 is not the same value as the 2/7 that he had as a training session beforehand. That is good. I think we're done. Then we'll move on to our problem set. Well done.